Hello everyone. Today we are going to discuss section 15.8 which is on triple integrals using spherical coordinates. Let me check my volume levels. Okay, so we're going to deal with that. So as we explained, first you studied double integrals over rectangles, then you studied over the general regions. Then you studied double integrals over using polar coordinates. Okay, polar coordinates. And remember, if integrand equals 1, then the double integral will give you the area. Okay, and if the integrand is a function of the variables x and y, then the double integral will give you the volume. Okay, so then we studied triple integrals. Okay, triple integral we studied over a cube or with definite limit, that's what I meant. And then we discussed about general regions. In general regions we said we could go dx dA, that means we could integrate with respect to x first, or we could go dy dA, or we could go dz dA. Okay, then after that we said when you do dA you could get into polar coordinates. And we said if the integrand equals 1, am I on the screen? Yes. If the integrand equals 1, then triple integral would give you the volume. Okay, if the integrand equals a function xyz, then triple integral would give you mass. Okay, that's what we discussed in the previous lecture. Now and also we said triple integrals also you could evaluate using cylindrical coordinates or spherical coordinates. Yesterday we saw using cylindrical coordinates. Today we are going to see using spherical coordinates. Okay, and in the spherical coordinates, so it's based on the sphere. Okay, so one thing is you want to replace x as rho, I don't know, x is r cosine theta, right? So r is rho sine phi, so rho sine phi cosine theta. I hope I'm right. Let me check my work. I don't know where my work is. Okay, where my work is. Yeah, and y is gonna be rho sine phi sine theta, and z is gonna be rho cosine theta. Okay, so when you do x squared plus y squared plus z squared, then what you get is you get rho squared sine squared phi cosine squared theta plus rho squared sine squared phi sine squared theta plus rho squared cosine squared theta. So what does that give you? When you factor out rho squared sine squared phi, you get cosine squared theta plus sine squared theta plus rho squared cosine squared theta. So that's cosine squared plus sine squared is 1, so that gives you rho squared sine squared phi. Oh, z should have been then rho cosine phi. Okay, not theta, it should have been rho cosine phi. Okay, then that's going to be rho squared cosine squared phi. So now you can factor out a rho squared. It's going to be sine squared phi plus cosine squared phi, so that's going to be rho squared. So what do we mean by that? I mean, you're really looking at a three-dimensional, I hope I can make it clear, 3D. Then your x value, it's going to be whatever angle. Let's say if you take this point here, okay, then this is going to be your phi, that angle. from the positive z-axis, and this length is going to be the rho. And when you project it into the xy plane, I mean where the theta is going to be, let's just say this is theta, so that's going to be theta here. So that is the point in the, that's what is the theta. That's it. Now remember, rho is a radius, so it has to be bigger than 0. I mean, if it is 0, then you're talking about no sphere at all. And theta can vary anywhere from 0 to 2 pi, and theta is a positive angle from the positive x-axis, and phi is going to be from 0 to pi. Now this gets interesting. This is what is interesting. Why is it pi and why is it not 2 pi? Okay, now I don't know how to say it, but let me make a picture for you. Let me make a picture for you. I don't know how quickly can I get it. Okay, I'm gonna, okay, this is gonna be my rough sketch. I hope I did not do anything. Okay, I thought I messed up, but let me see. If you look at it, this is my this is what it is. Now if I move my theta like that, that is theta is 2 pi, you see, but this is phi is from 0 to pi. Does it make sense? Or in other words, I just need one part of the semicircle to rotate for 2 pi degrees so that I can get a sphere. I don't know if I can see it. This is my semicircle, so if I rotate it like that, then if I sweep it by 2 pi, then I get a sphere. But if I take 0 to 2 phi to be 0 to 2 pi, then if I rotate it for 0 to 2 pi, then I get 2 revolutions. I don't want to get 2 revolutions. I want to get just 1 revolution. Okay, I hope that is clear. If not, just let me know. I will explain it more. And when you integrate, you want to replace dv by rho squared sine phi d rho d phi d theta. Okay, why is that? Because of the change of variables. How do you evaluate that? That's going to coming up in the future sections. Okay, now let's take a problem and work on it. Let's take a problem and work on it. Use the spherical coordinates to find the volume of the solid that lies above the cone. Z equals square root of x squared y squared, and below the sphere that. First of all, we are finding the volume. If you're finding the volume, you want your integrand should be 1. Remember that it should be dv over the entire domain D, because if there is an integrand here, then you get the mass. Remember that. So here we are finding the volume, so the integrand is 1. That's a giveaway. Okay, now you really remember, it's going to be a long problem. I hope we stay together on this. It's already 8 minutes. So the first thing is you want it above the cone. So I hope I can draw it. This is the cone I have, and this is a cone. I mean, if you square both sides, you get x squared plus y squared is z squared. That is the cone above and below, but because you are only wanting positive values, so it's only referring to the positive part above the cone, or the top half of the cone. Okay, and then and below the sphere, x squared plus y squared is z squared. So that's what it is. So it's like an ice cream cone, if you wanna look at it. That's what we want, like above the cone and below the sphere. Okay, so let's look at it. I mean, is it focused enough? Let me see. Okay, that's focused enough. So let's start with this one. I mean, z is going to be square root of x squared plus y squared, and the next one is you have x squared plus y squared plus z squared is going to be z, right? So that's going to be x squared plus y squared plus z squared is going to be rho squared, and z is going to be rho, what did I say, rho cosine phi? Maybe that's what I said. Let's just check that. Z is rho cosine phi. Yeah. Now remember I said rho has to be bigger than 0 because rho is the radius of the sphere. If it is equal to 0, then there is no sphere. If it is negative, the radius can be negative. So you can divide both sides by rho. So you get rho is going to be cosine phi. Okay, there we get rho is going to be from 0 to cosine phi could be one of our limits. Okay, the next thing is this, right? I mean, let's see this. Now squaring both sides, you get z squared is x squared plus y squared. Then or let not just square both sides. So you get z is going to be rho cosine phi. I hope I can be able to write it. Equals square root of rho squared sine squared phi cosine squared theta plus rho squared sine squared phi sine squared theta. Okay, that's what it is. So now that's going to be rho cosine phi is going to be square root of rho squared. You can factor out as sine squared phi. That's going to be cosine squared theta plus sine squared theta. Okay, so cosine squared theta plus sine squared theta is going to be 1. So that's going to be rho squared sine squared phi. Okay, that's going to be rho cosine theta is going to be rho sine phi. And when you divide by rho, these two gets cancelled out. So you get cosine. Oh, this is v is rho cosine phi. This has been phi all along. Cosine phi is going to be sine phi, and that happens. All students take calculus. It happens their cosine and sine are equal either in the first quadrant or in the third quadrant, but phi is only between 0 and pi, so that means phi has to be pi over 4. Okay, that's another limit. So phi has to be from 0 to pi over 4, and we're getting rho to be from 0 to cosine phi. But now theta is going to be, because it's going to, the limits for theta is pretty obvious. It's going to be 0 to 2 pi because it's going to be sweeping across. Okay, that way you get the whole thing. So I hope this is clear. Now you want to find the volume above the cone and below the sphere. So it's going to be integral domain d1 dv. Remember, again, I'm recalling volume means integrand has to be 1 in triple integral. Now could you do this in with using double integral? Maybe not, but the problem here is we are given z, so we have to run with that. Okay, so you have integral rho squared sine phi d rho d phi d theta, and this is going to be 0 to cosine phi. Okay, and for phi it is 0 to pi over 4, right? And for theta is going to be 0 to 2 pi. I hope I'm clear on that. Okay, now we have to start integrating stuff. So first, when you integrate rho squared, I mean, everything is treated as constant. So when you integrate it with respect to d rho, so that's going to be 0 to 2 pi, 0 to pi over 4, and you get a sine phi integral 0 to cosine phi and a rho squared d rho d phi d theta. So that's going to be 0 to 2 pi, 0 to pi over 4, you get sine phi, and you get rho cubed over 3, where your limits of integration is 0 to cosine phi, and you get d phi d theta. Okay, and that's going to be, you get 0 to 2 pi, 0 to pi over 4, you get sine phi, you get 1/3 outside, and that's going to be cosine cubed phi. Okay, and you get d phi d theta, right? So now the question is, how would you integrate this? That's what is the big question, right? Let's go to the, or let's take it here itself. I hope that makes sense. So how would you integrate it? Any guesses? It has to be u substitution. You want to say u is cosine phi, so you get du is going to be negative sine phi d phi. Okay, So that means I'm gonna just integrate that. Okay, cosine cubed phi is sine phi d phi, right? That's what we have. So that's going to be u cubed in minus du. So that's going to be negative of u cubed du. That's going to be negative of u to the 4 divided by 4. Oh, negative u to the 4 divided by 4. And recall that your u is cosine phi. So that's going to be negative cosine to the 4 phi divided by 4. Okay. So back substituting and your limits of integration like 1/3 integral 0 to 2 pi, you get a minus sign and times 4 in the bottom also, and you get cosine where your limits of integration is going to be 0 to pi over 4, and this is d theta. I hope you are with me on that. And so that gives you negative 1 over 12, and this is integral 0 to 2 pi. When I substitute that, I get cosine for pi over 4 minus cosine for 0, and the limit of integration is d theta. Okay, it's too little, but I hope you can. Negative 1 over 12, 0 to 2 pi. Cosine pi over 4 is 1 over square root 2, but when you multiply it 4 times, you get 4 and 4, 16, so 1 over 16 minus, that is going to be 1 in the d theta, right? So that's going to be negative 1 over 12 integral 0 to 2 pi, that's going to be negative 15 over 16 d theta, right? So when you distribute it, you get 15 divided by 16 times 12 or whatever. Okay, maybe we can do 3 4s and 3 5s here. So 5 over 64, right? 5 over 64, where your limit of integration is integral of d theta is theta, and upon substituting you get 2 pi minus 0. So 2 goes into 64 32 times, so you get 5 pi over 32. Did I make sense? I hope. If not, we have to figure it out where I made a mistake. Okay. Cosine 4 is 1 over square root 2. 1 over square root 2 times 1 over square root 2 is 1 over 1 half. Oh, this must have been 1 half, right? 1/4. 1/4 minus, oh god, I made a mistake from here. So, okay, so let's go to the next page. That should have been negative, am I on the screen? No. Negative 1 over 12 integral 0 to, or whatever we have, right? 0 to 2 pi. 2 pi, and you had a negative 3/4 d theta, right? So 3 goes into the 12 4 times, so positive, so you get 1 over 16 integral d theta, where your limit of integration is 0 to 2 pi. So that's going to be 1 over 16 times 2 pi minus 0, that's going to be 2 pi over 16, so that's going to be pi over 8. Okay, that's what is the volume. That's the volume of the region bounded above by the cone and below by the sphere. So next time you eat an ice cream, you know the volume of the ice cream is pi over 8. God, that's less than 1. Okay, I hope this is clear. And what did we do in this video? One is we described what is the spherical coordinate here, and we said the radius has to be positive, theta is between 0 to pi, and we explained why phi is 0 to pi. And if you're going from rectangular to cylindrical, you need to make a change in variables, you do that, and I show you why that is justified because of that. And I gave you a preview of what happened in the previous class, and then we went over an example here, right? Not this one, maybe this one. We went over this example. I thought this was a little more messy problem. So first what we did, we got this is what was step 1, and step 2 was here, getting the limits for phi, and step 3 was identifying that, and step 4 was setting up the integral here, and after that we went through, I made a mistake but I fixed it, okay, and getting an answer. Okay, I hope this is clear. If you have any questions, please let me know. I hope you understand this, and I hope your family is safe and healthy. Bye bye.